do the testing of our data and how we are validating it, right? So for that, we are having different techniques uh, to do the validation. My voice is echoing. Is my voice is audible and it's clear?
Yes, sir.
For when we are designing a machine learning algorithm, thing is we have to choose which portion of uh, data set is going to be act as a training data set and which portion is going to be act as testing data set, right? That is one thing. And one more thing, which algorithm we are going to use. Uh, for example, there are several algorithms available for classification, several algorithms available for predictions. Let's say, for example, supervised learning itself, we are having n number of models available. So we have to choose which model is more suitable for our algorithm. How we can do it? For example, let's say we can take SVM and a tree, and we have to compare which algorithm we are going to use it and which one is best suitable model for our system. How we can do it? For that only, cross validation come and play a role to identify which one is the best machine learning algorithm for our model. Uh, let's say in this example, there is an historical data to identify whether a person is having a heart disease or not, or otherwise there is a symptoms called chest pain, blood circulation unblocked in weight. Based on these features, whether we are going to predict whether a person might have a heart disease or not. So we have to identify that one. So for this one, as I said, we are having k nearest neighbor, SVM or logistic regression. Among three, which one is the best suitable one? How we can predict it? For that, what we have to do is we have to use our training data set, and we have to evaluate each and every model, and based on the results of all models, we have to based on the results of all these models comparison, we came to know that either SVM or k-means or logistic regression is going to work well for our model. So for that, we are going to for that we are using cross validation. What actually cross validation? Cross validation is nothing but how we are going to use our data set for the testing. Let's say as in the morning session we have spoken about a 70-30 principle, right? 70% of our data set is going to be used for our used to train our model, whereas remaining 30% is going to use for the testing, right? In that case, let's say let's say for example in this model, uh, in this image we are taking four folds, which means our data set is divided into four blocks of same size, among in which three blocks are going to used for our training, whereas the one block is going to used as testing data set. Here there is another question, whether the last block is we are going to take that as an test data set, or why not the block in between, right? Third block or second block, which block we can take so that our results will be more accurate, and our testing will be our training and testing will be more sophisticated. So here only the cross validation is doing a job where it is taking all the blocks as uh, testing. Let's say initially for to compute the k means, for computing k means algorithm itself, it is taking first block for testing first time, second block for second time, third block for third time, or fourth block, or likewise. All the four blocks will be, among all four, one block will be used for testing at a time. In such a way, all the combinations of testing results are computed, and the cumulative results, combinations of all these four results, which means the first results with the first block, or second result with the second block, third results with third block, or and so on. If we are taking four, then we will get the four different results. All those four different results will be combined, and the cumulative results will be given as a k-means results. Likewise, SVM. Likewise, logistic regression. In that way, we can cross-validation help us to identify the uh, help us to evaluate our system with testing data. So this is the case for four-fold cross-validation. If you are dividing our entire data set for into four blocks. Let's say initially how we will do, the entire data set will be used for training. The same data set will be used for testing. Is it any meaningful? No, right? Because all the data will be already trained. Then the same results if we are using for testing, then our results will be the same, right? The predictions or classification will be same. But it is not the case actually. So that only we are going for separating training and testing. So the best practice is usually tenfold cross validation, which means the entire data sets will be divided into 10 blocks. One block at a time is used for among which one block size will be used for testing, and it will be iterated 10 times with different blocks. Let's say block 1, block 2, block 3, up to block 10. So all the 10 results will be cumulated, and the cumulative results of SVM, logistic regression, or the linear regression will be given as cross-validation results. So this is called four-fold cross-validation or tenfold cross-validation. Among which, to make the better efficiency, what will be the ultimate solution is each data item will be tested individually, which means leave one out cross-validation, which means the entire data set of, for example, if we are having 100 rows in a particular data set, then that will be in terms of 100 cross validation will happen. So for every validation, one block will be leaved, remaining 99 will be used for training, and the left out block will be used for testing. In such a way, leave one out cross validation will take all the block for testing. So on that time, remaining 99 blocks will be used for training. So in such a way, it will be our cross validation will help us to test our model more efficiently. So that way, the cross validation will help us. What is the results of cross validation? Let's say, for example, it is a matrix, right? Either a confusion matrix or ROC or LOC graphs, right? So we have to understand what is the use of confusion matrix and what the confusion matrix actually do. For example, the same example, heart disease. Uh, there are four rows. One is actual, and two columns of actuals and two rows of predicted, which means uh, actually what the data we are having. Whether if we are having 10 data entries, which means 10 person detail, among in which whether four persons has heart disease and six are not having heart disease, which means that is the actual results. In which means has heart disease, actual that will be actuals, whereas in the predicted, among the four, how many correctly predicted whether that person has heart disease, that is called true positive, which means among the truly affected heart disease affected persons are identified. How our system is identifying correctly out of four or six, how it is correctly identified, that rate will be given as true positive. Whereas false positive is the rate where actually that patient is not having heart disease, but our system predicting that that patient is having heart disease, which is false positive. Actually, that patient is not having heart disease, but our system saying that that patient has heart disease, which is false positive. Likewise, if a person actually having the heart disease, but our system is predicting that person is not having heart disease, then that is called as false negatives. Then what is true negative is the person not having heart disease, and the system is also predicting that the person has not having heart disease. That is true negatives. So actually, our algorithm aim is to true positive and true negative should be the sum of true positive and true negative is equal to total number of samples. In that case, our system is predicting 100% is efficient, but it is not all the times. So it is not the ideal case. So always we will get the prediction classification less than 100%, right? So with this matrix, what we will do? So with this matrix, we can go for identifying what is the sensitivity and what is the specificity of the given problem. What is meant by sensitivity and what is meant by specificity? Which means you can see it in the next slide. Whereas sensitivity, what the sensitivity is telling about is how many percent is having heart disease are correctly identified out of in which actual heart disease patients. That is called sensitivity, which means let's say true positive out of which true positive plus false negatives. Actually, the actual number of cases which are having heart disease is sum of true positive plus false negatives, right? Out of in which how many are correctly identified. Actual actual heart disease affected patient out of in which how many are correctly classified. That is the sensitivity. Whereas specificity is how many are not having heart disease out of in which how many are correctly identified that that person is not having heart disease, which is termed as specificity. Why these two parameters are important? And when we have to focus on sensitivity, when we have to focus on specificity. For example, for a given problem, there might be sensitivity percentage probably 80%, then specificity probably 85%. Then whether we have to go with this model or not, based how we are going to identify whether sensitivity matters or specificity matters. That is depends on the problem which we are addressing. For example, to identify particular person is obese or not, if a particular patient or particular human being is obese or not, to identify that one, whether sensitivity is a matter or specificity is a matter, which means whether a person actually having obese, that has to be identified using the sensitivity parameter, whereas specificity parameter indicates whether the person is not having specificity, obesity. So which one is the higher most important in this problem is it's highly depends on the criticality of the application. For example, saying non-obese person is obese, it's not a big problem, right? If even our system is classifying that also, which is not going to impact any critical things, right? So that case, we have to go for specificity. Whereas to identify a corona patient, let's say if a person is having corona or not, to identify that one, whether we have to focus on sensitivity or the specificity, which means sensitivity always tells us that the person having the corona has to be identified correctly. So sensitivity percentage should be high. So in that case, we have to focus the sensitivity parameter. So likewise, confusion matrix give us the clarity that which one has to be which one percentage has to be taken more advantage. The same thing has to be sensitivity and specificity are denoted in terms of precision and recall and FMSs. So precision, recall, and FMSs are computed based on the data given by the confusion matrix. So that case, confusion matrix, specificity, sensitivity are playing a major role by for evaluating our algorithm. So let's say I'm going to open Orange. Yeah, this is morning. I try to show this welcome screen where in the welcome screen we can have new screen. Whereas if I click new, I will get the plain canvas. Whereas open, which will allow us to open the already saved workflows, which means if I'm working on one workflow and I'm saving it for future use. So once I click open, then I can get the already saved workflows in the open region, whereas recent is used to open the most recently used one. The among all those things, the important things with Orange is it is providing very neat and clear documentation, video tutorials, and clear examples. For example, if you are clicking examples, we are having different examples for the different kind of workflows we are doing. For example, cross validation. We are talking about cross validation, right? To work on the cross validation, there is an uh, predefined workflow is example is given here. So we can use this one and we can work. We can create our own workflow, or even we can use the examples provided by the Orange. So for example, hierarchical clustering or feature ranking, or what is misclassification, or principal component analysis, how we are going to do it, or classification tree, or visualization of data subsets, iterative visualization, file and data types. So all these things, there are predefined examples available in the Orange. That one thing. And one more thing, video tutorials. There is an Orange supporting video YouTube videos. We can directly use that video and we can explore the basic things. This is uh, and the documentation will give the uh, clear usage of each and every widget. For example, if let's take file widget, then the file widget, what are all the file types it is going to allow and how we are going to use it. Everything will be clearly documented. So, which is the extra advantage that Orange tool is providing us. For example, if you are using file, it is reading XSL, TXT, CSV file, and comma separator file and URLs, right? That already we know. The same way, if you are going with SQL tables, so it is describing what are the SQLs we can use. Uh, SQL servers or Postgres SQL we can use, right? So likewise, each and every widget, there is some clear documentations provided by Orange tool. For example, unsupervised learning, how we can use k-means and what are the options available in the k-means. So everything will be clearly given the documentation by Orange. So in the phone session, my Orange got crashed. So as I shown, this was the default widgets come in handy once we are started with working. For example, if I am going, um, ceremony, ma'am. If you have any query, ma'am, hello. If not, please mute it, ma'am. So this is the way we can install it. For example, now I am going to install image classification and text, and it will take some time. So for easy things, I am installing now. Okay. For the time being, I'm just going to let's start with the practical sessions which are already we are having. So to start with, initially we can, I'm just going to open on dataset and we can start with visualization. Then we will go to supervised models, then unsupervised models with plain datasets. Then we can go with image classification or image. We can work with images next. Then we will go with documents. Then finally we will go for geo-specific examples. So that case, I'm going to show this iris datasets visualization. While another one more advantage of Orange is once we are opening a particular data sets or particular data source, let's say Excel or everything, here itself we can able to see how many are the instances. There are 150 instances in 4 features. There is no missing values. Then it is comes under classification. Why? Because the target variable is a target variable class is 3 different values only. So it is a kind of classification data sets. So for example, if I am going for Titanic data sets, here it is also classification classes. Either Titanic dataset is nothing but based on the event happening in the Titanic ship, right? So in that one, how many are survived or how many are died? So that is the dataset for Titanic. For example, if I am taking housing dataset, this is a regression. Why? Because that there is a no target variable so far fixed. In the target variable also it is a numeric in type. There is a no categorical value. So here itself we can able to find the data set is a which kind. So for example, if I'm taken a brown selected data set which is classification data sets. If it is a heart disease data set, it's also again a classification data sets. Or zoo data set is a classification data set. Among in which only one data sets which you are having is uh, regression is housing dataset, right? How is housing dataset only the regression datasets. So far, this is the sample datasets provided by Orange itself. So I'm just using that datasets to explain the basic things. For example, let's go with iris datasets. Iris dataset is nothing but classifying a particular flower based on the features of its sepal length, sepal width, petal length, and petal width. Based on these 4 features, our particular flower is grouped either iris setosa or vesicular or virginica. These are all the 3 different uh, classes or groups. Based on the 4 features, we are able to classify. So I'm just going to see this one in table format, because as I shown, this iris dataset is a tab separated file. For example, this is the dataset file. So if you are seeing, this is a tab separated file, among in which this column is a very important column. I will explain this one. What is meant by C and what is meant by D? C is nothing but column it indicates, or continuous values it indicates, where D is a target variable or D is a discrete variables. So it is D is indicating discrete, whereas this class is indicating this column is the class label or the target value. So this class will be used to indicate that this column values is the target variable. So this is the class variable. So these are all the continuous values columns, whereas this is the D is a discrete variables. So that is what this is the metadata of a particular data set. This is very important once we are opening working on the user defined data sets. So for that we have to understand these things. So I have to see this data set in a table format. So see here, simply I can drag and drop, and I can connect with the table, and I will get all the values are clearly separated and loaded in the table format. Okay. So if you are giving visualize, that's what orange has visualization better in terms of visualization. So if you want to highlight within colors of different three colors, then it is highlighting. So these are all just an options. So if I'm using a scatter plot, morning I have shown, here itself we can visualize different features, and we can see whether which feature we can take to classify this. This is a classification data set, right? So which features we can take so that our classification is better and accurate. So for that we can simply compare, and we can find which is the best one. So either cutter width or cutter length. The thing is, there should not be any overlapping, right? The minimizing the overlap region is the ultimate aim, right? So if our data points are well separately classified, then we can say that this is the exact features which is used for us to classify. So scatter plot is used to visualize this one. Here it's from in which also, as I shown here, either I can use the data as a data, or if I come, if I add table contents to this data, either I can use all the data to the scatter plot, or I can go for some selected values which will be highlighted here. If I giving in the workflow data to data subset, or selected data to data, which means what are all the values I am selecting, which is going to be populated as a subset data. For example, if I am selecting these four, see if I what are all the, it is floating. What are all the values I am highlighting, which is highlighted here, red in dark red circle. These are all the points where I have selected. So what are all the points I have chosen, which is given as a selected data as a subset to the scatter plot region, so that in this way we can able to identify what are the overlapping flaws, and those values we can manually analyze whether what is the reason for this misclassification and all. So likewise, we can by clicking the links between whether we can map all the data to data, or selected data to data, or data to feature. For example, I have to select a particular feature. For example, there are four features available. So I have to uh, go for that. For that we can go for PCA. Then from the PCA result, which is the best feature we can identify, then that we can use. That I will explain in the PCA thing. So this is the way we can visualize the data. For example, scatter plot we can use, or box plot. See, if you are going with box plot, we can able to identify how those things are well separately classified. For example, if we are taking supple length with then how those things are classified. For example, the line in the yellow indicates the correctly currently it's classified and where it has to be classified. So the overlapping region between iris versicolor and iris virginica is presented here. When we talked about based on the supple length we have classified, if we are giving with a petal length, that our box plot is saying that if you are go with petal length, then it is classification is more or less not overlapping. So likewise, we can identify different visualization technique, not even going for classification or any tools. We can, with the visualization itself, we can able to identify or analyze. We can able to analyze the data. So here, once I have created this workflow, for example, for visualization workflow, I have used this one. Once I have used this one, I have to use the same thing for in the future, right? So I can give save. Once it is saved, then I can use it uh, in the future by using by opening using the open options. So Likewise, I already created saved few workflows which I will explain it. For example, currently I have seen this visualization, right? So I have deleted and I'm opening the visualization already I have used. Okay, which is time series is mixed. Time series. Thing is, once I have uninstalled all the packages which I previously used were uninstalled, so I have to install it one by one. Mm, Let it with administrative privilege. If I install it, it will be fast. So I have to go for run as administrator. From here, I'm going to go for add-ons. I have to go for text time series, image classification, geo, and bioinformatics. Let all these things have, let it install. In the meantime, I will explain how we can create our own user-defined datasets. For example, so if I want to create our own user-defined datasets, how we can do it? Either way, we can use the Google spreadsheet or any file with tabs separated, as even with the notepad as I shown in the iris datasets. We can able to give the data sets based on the columns and with the metadata, we can able to create our own user defined data set and we can analyze. So likewise, if I'm having, there are 6 features with this one, I'm going to identify whether this is in which class. So if so likewise, this is the way we can able to create our own user defined data sets. So for that, uh, or if you want to get, as I said, already available data set provider, from there we can able to get it. For example, machine learning, diabetic data sets. These are all the data set I have used. I have I have taken for my analysis. So if you are going for this data set, what it will actually having is based on the these are the column formats, right? This values will be we are able to visualize once we are opening the orange data sets. In the bottom line, we can able to get right all the column field and its types, whether it is a new continuous value or it is an regression types or it's in classification, and what is this order of the columns and what it indicates, everything will be given in this data sets. From here only I have taken the data sets the same, not the exactly same. I have using this features, then I have changed a few values and I have created. So if no need to take the data set, either way you can give the GitHub link. From there, directly from Orange, we can able to download the data sets. It's not installing. I don't know what happened to my system. So from this, the class labels will be either person having diabetes true or positive or negative based on these details. Likewise, I have used this data set. I have created this data set uh, for user different data set example. I will explain this. Um, Sorry for the misconvenience. The tool is not opening. Okay, let me uninstall and install it. Uh, in the same um, one more thing in the orange is not only we can use use orange tool and directly as a already available widgets. We can able to create our own user defined widget.
Sir, excuse me, sir. Your screen is not visible.
Yes, ma'am. I have actually stopped. The tool is not opening. I just uninstall and install it again. So,
Okay,
you know,
sir. Okay, sir.
um, let me do the thing parallelly. I just don't. Uh, the thing is, straight away whether we can use the same already available widget, either whether we can create our own widget using Orange. Yes, that is possible. It is an, as I mentioned, it's a tool written on top of Python code. So what we will do is we can create our own widget. Uh, we can create our own widget and we can have as a add-on into the Orange tool. Let's say how we can do is as in the morning session I have shown uh, each widget having only two things. One is input and another one is output. It is kind of each widget simply we can let's say simply what we can say is this is all kind of functions. Let's say in the functions, C functions, the function has input and output, right? Same way, uh, if you are creating your own, what we can say, if we are creating our own widget, in such a way we have to create, there should be set of variables for input, set of variables for output. So if you are defining that variable and you can if you have created, then that if you are creating such that let me delete few things. I'm just doing the uninstall things. So sorry. So as I said, if you are writing in a function, what the function has to do. For example, instead of using the file widget, which is provided by the Orange, if you want to do the same thing with your own code, yes, you can do it. Uh, the input variables has to be read through the input variables. As for if you design a file widget, that should only the output. The input has to be read from the file. For that file read option only, we have to write the things in the Orange tool, right? The function has to be written like that. So likewise, you can create your own widget using the Python code and you can embed as with Orange. In the vice versa also possible. What is that vice versa is, already the component is available. You are having a Python workspace or you are working on Python code already. If you want to use the Orange widget there, instead of writing the same functionality in your Python code, how we can do is you can create your you can just import orange as a module, right? Like it is a numpy module. Orange is an yet another module supported by Python, so you can directly import that orange module inside your Python code, and you can use each and every widget instead of writing the same functionality in your Python code. These two also possible. uh, with a Python code, you can able to write your own, you can able to create your own widget, and that widget you can add as part of Orange tool, or you can use the already existing Orange tool inside your Python code by importing import Orange module. For example, it is same like importing NumPy module or importing a predefined, let's say if you are familiar with Java or C or C++, whatever the packages we are importing, java.utils likewise. Orange is also an utility package available as part of Python. You can directly use that too. That option is also possible in the Orange tool. My tool is installing. Maybe a few minutes. Um, it is taking a while. Um, it is installing. At the same time, I just want to explain few things like what are the things I'm going to use for the image classification. Let us discuss that thing. For example, I'm having data sets containing all the domestic animals. For example, the domestic animals of all kind, animals with two legs or animals with four legs, whether it has some feathers or cows. So all these images I have used. uh, with these images, what I'm going to demonstrate is from these images alone, how the features are extracted and those how those features are used for classification using the image embedding or options like image embedding and image clustering. So those things for that hierarchical clustering, we are going to use these images, domestic animals. And one more thing, there is an three different car groups I'm having. Whether the car group having a cheaper rate or expensive one or with a mid-range one. So I am grouping these three with three different groups. So by giving this folder, I can able to categorize these cars into three different labels. The things I am trying to say here is, as we have seen the values in the class labels, right? In the iris data sets, the data is grouped into three different groups, right? How we are grouping the images is by giving the different folders. So this is the way we can give the classifying the labels into the groups, and that groups will be given to the classes. So instead of mentioning anything like it is a cheaper one, or there is no meta types explicitly provided. Rather, it's just going to take this folder car3 as an input, and by Orange tool itself, it is able to identify these are all the classes, and among in which based on the features extracted from the images inside the particular folder. Likewise, it will be automatically identify itself. The same way, if you are seeing in the user-defined data sets, even if you are not mentioning the target class, only if you are mentioning the set of features from that itself, the tool can able to identify themselves what might be the target variables. So if any particular target variables is given, then with that variable, whether we can be able to accept or we can able to manually change the target variable. uh, uh, the thing what I'm trying to say here is, for example, if I am opening iris dataset, here giving this iris is a column which is the target variable. So if you want to change this one, you can able to change. For example, I am going to change, this is a metadata, I am going to change, it is a text one, and I am going to change some other column as a targeted one. So likewise, we can able to change those variables. That's what I'm trying to say. If you want to work on different things, you can able to change like that. Let's see. Let me open the workflows, like decision tree. Let's see the example of decision tree. How the decision tree will work. For example, I am taking again iris dataset for better understanding. Otherwise, I have to explain each feature of a particular dataset, and then only we can able to proceed. So I am using iris dataset. As we know, based on these four features, iris dataset is going to be classify the thing, but we have to know which is the most suitable feature in which the classification accuracy will be better one. So as I explained in the binary tree, which one is the top node, that is the best feature, which is exactly classifying the things, right? So based on our thing, petal length is the based on the tree. If you are using a machine learning tree widget, from in which we can able to identify if you are using petal width as the topmost root, then that will be classifying iris setosa separately, which is 100% separately iris setosa will be classified. Then there is a based on the petal length. After that, if you are using petal width, then which is again classifying iris virginica and iris versicolor with the percentage is given 90.7 percentage and 97.8 percentage. So that this way we can able to identify which feature is exactly classifying. So the same thing we can able to visualize in the scatter plot, right? For example, in the tree viewer, it is saying that iris setosa, if we are using petal length and petal width, then that will be classifying the things correctly, right? The same thing we can able to visualize here. If you are having petal length and petal width, see here itself, iris setosa is separately classified. So by either using the visualization, we can able to get it. But this is a simple example we are getting like this. So if we are having real-time data, we are not able to identify it. So if we are using decision trees, tree model to identify which is the most suitable feature, so from in which we can able to take the most suitable feature. The same way, if we are using continuous values instead of categorical values, we have to use if it is a more number of feature in our data sets, we can go for PCA, right? Principal component analysis, which is help us to identify which component we can take so that it will give the better results. So instead of unnecessarily having all those all uh, let us say all the features. So only meaningful features only used, right? So let us open PCA. So for PCA, uh, I have used zoo dataset where there is 18 features. There are 18 features in the zoo dataset. So using the PCA, I have to identify what are the features I can, what are the principal components I can take so that our algorithm is efficient one. Rather making all the features, there are 16 to 17 features. If I take all the features, then only my classification area under curve will be 100%, right? But if we are taking which percentage, which is more reliable for my algorithm, which is more optimal solution, so I can took only those features and I can able to use it, right? So likewise, for that we can use principal component analysis. So so that way you can take those principal components. There are 9 principal components, and from that component we can able to categorize which these components will again uh, classify differently, so that uh, likewise we can able to identify. So for that we can able to use PCA. Hmm, I want few other packages has to be installed so that I can able to explain. I'll try text, images, bioinformatics. I'm image analytics and text time series. I'm trying to install it. Let it be installed for a few seconds. Uh, the reason for crashing my orange is what I tried was, as I said in the introduction class, either you can use orange installed separately or you can use the Anaconda navigator, right? I said so. What I did was I have used Anaconda navigator to install another orange in the same folder. So that way uh, there was overlapping of files which leads to crash my orange. That's what it happened. So as I said, in the Anaconda navigator you can have Python libraries like Orange Tool or RStudio, or you are having a Jupyter notebook, or you have a Spider workbook. So with this also we can able to use. So I just try to install the same same tool in the same folder. So it's actually crashed my orange tool. That's what happened. I don't know why it is not installing again. Let me explain with the examples so that we are not able to. I don't want to waste your time, guys. So I will just go with examples which is provided by Orange so that I no need to install it again. As I said, this is the example I have taken for hierarchical clustering, which is provided by Orange itself. Yeah, this is the important feature. One another important utility provided by Orange. If you are having a workflow, you want to explain another person what that how you are designing a particular workflow, right? So instead of giving entire workflow, there might be cases where you have to do some pre-processing stuff like either we can able to remove few variables or we have to change the columns, we have to transpose a few rows to some columns, but if you are work on that, then this, if you are in a collaborative iterative development centers, there are more than one developers work on the same workflows. In that case we have to mention the other developer what the purpose of this step. So each and everything has to be clearly documented, right? For that, the Orange is providing an external feature by adding the text fields. So here, if you see it in the leftmost bottom, there is a field called text. If you click that, you can able to add the text and you can able to explain what this, for example, what is this name of the workflow. So like this, you can able to explain each and everything, which is very much important once if you are working with reverse engineering. So that those things we have to able to identify. For those kind of stuff also, Orange is supporting. These are all the minor. I know these are all the minor things, but the thing is, if you can able to know all these things, we can use this tool extensively to even write few scientific journals. If I'm not wrong, I have verified a few journals. Two journals will talk about only how we can use the Orange tool and how we can using the Orange tool, how we can do the classification and clustering. This these things only written in a paper and it got published. So like this, Orange has a stuff to support ourselves. Okay. So let's go with clustering. As I said, to go for clustering, distance is the widget which is going to essential widget which is going to compute the similarity and dissimilarity between the data points, and it is going to give the matrix. With that matrix only, we are able to classify. For example, in this example, they have taken some brown datasets, gene expressions of Baker's yeast. So with these datasets, what they have taken, there are 183 instances, out of which 79 features are there. So there is a classification. There are three values. What those three values is? Either RESP or repo or procost. These are all the three class labels. So what they have done is they have used distance matrix to compute the distance between the samples, and they have displayed visualized those distance in the distance map, either by using a clustering or clustering with ordered values. So with the different colors, so this way we can animate the distance matrix, how those distance will be mapped in the clustering. For example, it is very obvious. It's there are 153 data points, which is there are more number of hierarchical clustering here, right? There are more number of distance samples are here. Let's say we can change this to some other data sets, either housing data sets or iris datasets. See, while we are changing these datasets, all the widgets are auto-populating, right? It is changing its variables. For example, if I am changing it into a Titanic dataset, see distance matrix will be automatically populated. So likewise, so if you are changing one value, it will be automatically populating with other datasets. So now I have used hard disease datasets. There are 303 instances or 13 features. So once the distance matrix is computed, then those distance matrix will be given to the hierarchical clustering, where hierarchical clustering will form the clusters. So if you want to visualize with the gender feature, it is giving this like this. So if you want to glucose values, or if you want to predict by age or chest pain, so it will be doing all those steps. So if you want to even more clear, I will go with iris dataset again. Let's say distance is computed. Here there are three different groups, which is iris setosa. These things are classified under this cluster, whereas iris virginica is classified under this cluster, whereas iris this is the cluster where there are overlapping happened between iris virginica and versicolor. So we have to see why this mismatch is happening, right? So for that, we can either select only those values, the overlapping region, and we can visualize in a table, so that we can able to uh, identify where actually that misclassification is happening. So here also we can reduce the depth, maximum depth, so that so while changing itself, it will be automatically. Those changes will be auto-populated. For example, if we are focusing on the overlapping regions, so I have to select these variables where the overlapping is happening. For example, here one iris versicolor is overlapped with iris virginica. So virginica. So these are all the cluster regions where most of the overlapping is happening. So I have choose this cluster. I have choose this cluster, which will be given as only selected data to data. So here I can able to visualize the selected data. These are all the values I have selected. So if we select these regions, then those values, now it is data to data. I'm going to change selected data to data. So see here, only what are all the regions having mismatch, I have to only select those region and I have to investigate. So I have chosen this region where iris virginica and iris versicolor are overlapping. So likewise, only I can choose this one. That value will be automatically populated to the table, and I can able to visualize why these things are happening. Actually, technically speaking, I don't know what is the reason and why it is not classifying the. It is completely based on the values in these four features, right? So likewise, we can. The important thing is by using hierarchical clustering. How the hierarchical clustering will be algorithm will be implemented in the machine learning is by using the distance matrix. We can use the distance map to compute how it is mapped between those things. Those are all will be computed. Visualize the these are all the things used for hierarchical clustering. Here again, as I said, the one variable will be compared with another feature and how it is the classification is doing. Those things will be seen using the box plot thing. So let's open in another widget where this was the example I have used. I have created, this is my own workflow, as you can see it in the example workflows. For the same workflow I have used for hierarchical clustering. For let's go for training dataset. Yeah, let's move to the training datasets. From the visualization, then we can move for training dataset. In the training dataset, what is the mean by training and what is mean by testing? As I told, right? This is the file where the training is happening. Training is nothing but the models I have chosen: logistic regression, tree, navy base, and neural network. Then input file I'm using is iris dataset. Iris dataset is used to then for the training models. Then that will be given to the prediction for the output, where this is the data where it is used for testing. So based on the models, I can able to identify the accuracies of trees here. This is the important parameters we have to analyze. Uh, Based on the models we are using for the tree, logistic regression, navy base, or neural network, what is the classification accuracy, among in which logistic regression and the tree models yielding the better classification accuracy of 92.6 percentage, right? Among which one we have to use, that's our choice. Where after in which classification accuracy, if you see area under curve, which means the data points, how those points will be mapped under the curve, which is better in the logistic regression. In such case, if you see, logistic regression is the best suitable one for the iris classification, right? So once I have identified a logistic regression is the best suitable one, then what I will do is I can save this model, which means save model means I can save this model so that no need to train the same model again using all these models, because already it is trained and it is identified. Iris is betterly classified by using the logistic regression. So I have identified that one, I have saved this model. So once the model is saved, in the subsequent things, I no need to train again. I can simply use the saved model and I can directly test the model, right? So this way we can eliminate the training process. Once it is done, I can save the model and I can reuse it. So for that, we can go for the model called save model. This is the widget. So if you are want to reuse it, you can use the restore model is the widget. You can able to use it. So this is the way we can able to do the training the data sets. This is the way we can able to train it. Um, this is what classification, how iris is used for classification, right? uh, Previously we are used for training data set. To train the data set, what we will do is we are different model we can connect with the data set, right? Then that data set will be the trained model will be saved. Instead, test and score is a widget which is used to uh, train all those models, and we can able to identify here itself. Instead of connecting data to all the models, straight away data will be given to the test and score widget, and all the learners, these are the learners will be connected to the model. Then that will be giving the results, among in which we can identify which one we can use. Here the as I said before, confusion matrix, which is a very important feature when we are going to compute sensitivity and specificity, or FMSS and recall computations, right? So for all those things, this is the results of logistic regression. This is the result of random forest. KNN is the result of this is the result of KNN. So let's see here. Uh, from in which, if you want to see from in the confusion matrix, what by using the KNN, what is the misclassified? For example, the color in the red are misclassified. So we have to see what is the value misclassified. So that value I can only choose. Those values will be displayed here, right? So confusion matrix even more drill down, and it will be help us to identify. For example, these four are the values which are all misclassified. So once we can take those four, and we can able to identify why it is misclassified. So actual versicolor, but it is these three. Actually, it is Iris virginica, but it is classified as Iris versicolor, right? This is the way actuals are given here, whereas predicted results are shown here. So this is the way, as I said, the sum of all the true positives and true negatives should be the actual results of number of entries in the datasets. In that case, our classification accuracy is 100%. So these are all the misclassified values, these 7. So those things we can able to see in the scatter plot also. This is the way we can train and test the classifications. I'm having image and text mining rank method. Okay, let's open rank. At least it's open. Yeah. Rank. If you want, if you are saying that I don't know what this rank tool is, rank widget is going to do. So I just blankly, I don't know. I don't know any concept of machine learning, but I just want to explore what this rank functionality will do. As I said, either you can go for documentation, or you can, by clicking this particular widget, you are having the help. So if you are going with help command, you can able to visualize what those rank actually will do. In this example, what I'm trying to say is, actually we know uh, while we are constructing the tree model, what we will do, we can able to compute the gain ratio. From the gain ratio, which is the maximum gain ratio, that feature will be taken as the root node, right? So likewise, we can able to compute. So same way, if you are having rank widget having all these parameters, which are all we are using for the either classification or clustering, or whatever the algorithm we are using. For example, if we go with tree, we can mainly focus on information gain ratio, gain ratio, and Gini ratio, right? So likewise, chi-square test or FCBF or ANOVA. So all these variable, all these rank computation results are computed using the rank widget. So this is the rank feature where we no need to compute, we no need to programmatically compute the values. All those values, computations are already given in as a function. We can directly use it. So by using the rank, then the rank will be given to the distance if you are go with hierarchical clustering or any type of clustering. Whereas if so same way, as I said, if you are go with PCA, which one iris dataset again? So iris dataset, we can know only 3 features. If you are going with the 2 feature, it is exactly classifying, right? So for this one, in the scatter plot, there is another important feature where find the informative projections, which is very important feature, which is supporting, for example, if I am choosing P2 and P3, which means it is not completely classifying correct, right? So if I'm giving find information informative projection, if I start, it is giving that if you are go with P, PCA1 and PCA3, which means principal component 1 and principal component 3, which is the most informative projections. So if you project like this, then our results are actually the classification results will be accurate. So this way it will be ranked. So if you go with PC1 and PC2, it is also classifying, but the let's say this results here it is showing how accurate it is. For example, if you go with PC2, PC3, it is very poor classification. If you go with P3, P1, P31 and P32, it is somewhat average. If you go with PC1 and PC3, it is a better classification. So there is an option for finding the informative projections. So these are all the handy features supported by Orange. So that's what, if you are going with PC2, I just want to compute only 2 principal components. For example, if you go with housing dataset, it is having more features, right? So I am going with the housing dataset. So housing dataset, so if we are having 4 feature, it is not propagating. It's propagated in the principal component. That should be all. No. It is not projecting. Yeah, explain variance. Hello?
Sir, your screen is not visible clearly.
It is not visible. Sir, come again?
Yeah, font size is very small.
Font size. Sir, now is it visible? Is it better at least? Sir?
Sir, sir, it's not clear, sir.
It's blurring or how it's displaying, sir? Actually, I don't know. Sir?
It's blurring, sir. It's blurring.
Up to so far, it is now only you are facing this problem, sir? Or,
Sir, starting session also same problem, sir.
okay.
Okay, sir, fine.
I don't know, sir. Probably it is. I am maximizing as much as possible, but thing is, it is inside the orange tool. I am opening another window. Probably that is the case. It is not visualizing it. Let me do one thing. Can I share all this workflow in the meanwhile? If I am explaining, you can also open it, sir. Is that okay, sir, for you? If it is okay, I will immediately share all the workflows.
Okay, sir.
It's
Okay, sir.
it is a matter of second. You can able to install Orange, sir. Is that okay, sir?
Okay, sir.
Ma'am, can you please help us to share the content, ma'am? How I can do it?
Sir,
How I can share the files, ma'am?
sir, please, what, sir?
I just want to share the workflows with participants, ma'am.
Mm,
Since my screen is the orange canvas is not visible, I guess it is somewhat blurred. It seems.
that I don't know, sir.
Hmm, what we can do. Um, Sir, otherwise, once the session is
Sir,
done,
sir, you maximize your screen, sir.
sir, ma'am, ma'am, I did at max.
Uh,
Is it visible now? At least,
yes, sir, visible, sir.
is it clear, ma'am? All the wordings or all the widgets,
Wordings are clear.
sir. Is it okay, sir? Now for you?
Okay, okay, sir. Fine, fine.
Yeah. Uh, Let me explain it here. Sir, once the session is done, I will share the workflows with ma'am. Probably she can explain, she can share with you through mail or I can put it in my drive and I can share the link, sir. You
Okay,
can get it
sir.
through.
Okay, sir. Okay.
Okay, then. So, as I said, this way only that rank will be given to the distance matrix and hierarchy clustering will be done. So, let's move to another workflow, schemings. Educational. Here the problem is that already add-ons are list. Is installing. Give me a few minutes. I will install, sir. It's image analytics, text. It's these three. It's almost done. Text category is installing. Okay. Set. Sorry, again my orange got crossed. Um, in the meantime, if possible, anyone can install Orange on your system. It is just a simple thing. You can just go and download the Orange Windows exe. It is just a matter of second. If anyone able to do it.
Sir, is there any problem?
Oh, yes, ma'am. Orange got dropped, ma'am.
Somebody have posted query in chat box also, sir.
Let me address it, ma'am. Optimization of parameters are possible, but no problem. Yes, ma'am. Optimization of parameters are possible. For that, parameter optimizations. Um, yes, ma'am. That is possible, but I don't have any hands-on for to explain that one. I will create one workflow with that example and I will share to you, ma'am, through Geeta, ma'am. I will explain that how give the documentation and with two workflow examples to you, ma'am. Surely I will do today. Probably let it install. I just go with the documentation provided by Orange so that Um, I will just explain the workflows. Sorry for the inconvenience. I know it is quite this unexpected thing happened. Sorry for that. For the image classification, as I mentioned, uh, for how we are doing the image embedding, as I said, for the image embedding is the feature, image embedding is the option which is used to extract the feature from the image, right? As I said, Google Inception V3 model trained on ImageNet, which is used to use the Google images. Then from there it is using the algorithm to get the image features. So there are a few more embedded used But image Google Inception V3 is I have used SequenceNet and Image V3 for the car example, among which I found Google Inception V3 is classifying better for the car examples. So probably I will try to use Inception V3 for all those things, but still we can use SequenceNet VGG16. Here, what those things are the using by different algorithm. We are getting a different number of features, and the maximum the order of features are varying, but the count of features is almost the same among all these models, which means it is going to fetch almost possible around 1,000 features per image is extracted in the Google Inception V3. It is Google Inception Deep Neural Network Image Recognition Model. See, this is an deep neural network implemented one. So see, this is an example where images are loaded using image embedded. Once image embedding is done, then we can able to visualize all the feature extracted from the image embedded using the data tables. Okay, for once the image embedding is done, we can use the distance widget to compute the similarity between the every for example domestic animals example. uh, then distance will be compared with each and every data every items distance features, then that will be given to the hierarchical clustering. So likewise, we can use the image classification. Whereas if you go for text classification, as I said, for text classification, uh, we can go for using the import documents option to get read a number of documents in a given folder. Then image corpus viewer. Corpus viewer is used to uh, navigate and used to search the elements or tokens inside the document. For example, if you are loading n number of documents with related to research and with related to education or with related to university, if you want to search only university, you can give the token. It will the documents only on the university will come. Then from there we can select those documents for the further classification. Likewise, corpus viewer is used to view and do some filtering kind of task. So from in which from the document viewer itself, at least I will, instead of running, I just going to show the workflows. Ignore missing widgets. Again, while adding, it's very. So, the important feature in the document gathering is an pre-process of text. For that, we can use the widget called pre-process text. Here in the pre-process text, what we will do is we can remove, we can do all those things like what we will do is we can remove the punctuation or stop words. How we can remove the stop word is we can has to type a few words in the text files. For example, I have used. This is the stop word text I have used. For example, these are all the stop words. I no need to get in the corpus viewer. So once I have typed all those words, then I can feed those fold those text into the stop word fold. Then that will be remove all those things, and this is the word cloud. Word cloud, which is get those words with number of occurrence. The word which is bigger in size has more number of occurrence in the corpus or the documents which are all uploaded. So likewise, this corpus, the word cloud will be formed. So if you want to remove the stop words, you can upload it, and then only you will get the meaningful information and meaningful pattern will be identified. Likewise, we can use the pre-processed text. So, if you want to do the same thing using the Twitter, if you can take the Twitter profiler, pre-process the text and back of words. From the back of words, we can see the word cloud. Word cloud will highlight what is the word which is highly majorly used in the retrieved tweets. In the tweets, we can go for sentimental analysis also. For example, there is a separate widget called sentimental analysis. If you use that widget, what it will do is it will take the let's say election 2020 or US election 2020. Then the tweets which are all given in election 2020 will be processed. From that, uh, using the Twitter profiler and the sentimental analysis. If you give it to the sentimental analysis, it will give the tweets which are all supporting Donald Trump and the tweets which are all supporting uh, the current US president. So those things we can use sentimental analysis, either the polarity of a particular tweet, either the tweet is positive or negative. For example, if it is supporting Donald Trump, or it is opposing, or it is a neutral tweet. So all those things we can get it using the sentimental analysis widget, which is giving either positive value or negative value, or the if it is a neutral tweet, it will do the zero value, otherwise it will give the positive number or it will give the negative numbers. So that way we can process the tweet. From Wikipedia, the same way, from Wikipedia, what we will do is Wikipedia search, the words which we are giving in the Wikipedia will be taken from internet, and the same thing, we can pre-process the text and we can view it in the word cloud. So unfortunately, I'm not able to show all those things in the example. Now I'm getting educational, at least. I will explain at least K means. Yeah. Let's see about K means, the paint. In the K-means, what we will do is we will give the input in terms of points, right? Data points. To give the data points, either you can use paint widget. Paint widget allows us to paint the things, paint the points, like just right-click movements. I will just click C1 and I will paint it. So once the data points are painted, and K-means widget is, yeah, in the K-means widget there is an important feature come in handy, which is slet and score. Slet and score tell us if we are how many cluster points we can classify, so that the points will be correctly classified. So it will give that, it is suggesting us which is the optimal cluster point. For example, if I'm removing few points here, for example, I'm going to clear, I'm just going to drop few data points here for cluster C1, the same data points for here, and for cluster C2 I have used data points. I can either glitter it, which means I can glop it. So this is the data point I have fed into. Then the, see, previously it was Slaton score was 8. Now after changing the data point, I am getting Slaton score is 4 or 6. So even if I am changing a few things, the Slaton score is varying. So likewise, in the k-means, we have to know, right, how many k value, how many it should be perfectly clustered. So for that, we have to compute manually the computations. We have to find by means or medians, and we have to identify it. Instead, we can directly use the k-means Saturn score, from in which we can choose the k, and we can be able to visualize it. The same thing will be visualized after the clustering. So if you want to see the same thing in the iterative clustering, as I said, if it is in iterative clustering, we have to given some data points. See, this is the data points given. So in the iterative clustering, what options we will get is uh, either number of clusters we can choose or randomized positions. So initially, anywhere in the data point in the map, we can plot, and we can recompute until all the cluster centroids are fixing to those points, right? So those will be identified in the randomized positions once fixed. So I will give the recompute options. All the points will be recomputed. For example, if I run this one, see, it is iterative clustering, given that how those clustering is happening. For example, if I'm giving 3 and I give a run, see, the cluster points are recomputed and it is displaying here. So likewise, it is used to explain how the recomputation and how the iterative clustering is working. If it is at least image, I can able to show the image analytics. It is with this image analytics. I will summarize. It's okay. Hello, ma'am. Ma'am, I have some network issue வந்துச்சு நினைக்கிறேன். சிஸ்டம் லோட் ஆயிட்டே இருக்கு. உங்களுக்கு விசிபிள் ஆகுதா? எனக்கு ஸ்க்ரீன் வரலையே. Uh, Sorry, everybody. Some system issues happening. So I just want to take the demo session alone for just 1 hour tomorrow. If anybody has interested, please let Geeta ma'am know so that tomorrow 1 hour I will ready to take all alone. Not the demo. If anybody interested, please she will let the time. Probably we can continue.
Thank. Shall we conclude, sir?
Yes, ma'am.
Thank you, sir. Dear participants, for your kind information, uh, I have requested the resource person. He is also ready to take a 1 hour demo, orange demo tomorrow. The participants who are interested can attend the tomorrow orange demo session. Timing will be intimated later in the group. The link will be tomorrow's link, same link. I think all may understood what I'm telling. Tomorrow, sir accepting to take 1 hour session, orange full demo session. Those who are interested participants can join the session. Timing alone intimated later in the WhatsApp group. Thank you, sir. Thank you for your valuable session.
Thank you.
Thank you, sir. And I thank all the participants for completing this relay session in successful manner. And request the participants to give the feedback without fail. It is already posted in chat box. Shall we end the session, sir?
Yes, ma'am. Sure.
Thank you, sir. Okay. And thank you, one and all.
Ma'am, please post the feedback once again, ma'am.